Now, slenderness of post. To avoid buckling failure, a further modification factor must be applied in the calculation of compression in timber post when it comes to the slenderness ratio. Now, with slenderness ratio uh, being equal to 5 or more, then we apply the modification factor. When it is less than 5, right? When it is less than 5, the modification factor is 1. But when it is greater or equal to 5, the modification factor has a value which is less than 1. And you have to apply it accordingly. And it depends on the values of slenderness ratio as per table 22 of the British Standard 5268. So this is something that need to be looked at. You have to determine the slenderness ratio. If it is less than 5, it is the ratio is taken at the modification factor is taken as 1. If the slenderness ratio is greater or equal to 5, then you have to use table 22. Slenderness is dependent on the slenderness ratio and on the ratio of the modulus of elasticity to compression stress. Now, as per table 22, these are the two parameters you need to be able to determine the modification factor. Now, slenderness ratio of post is given by, is determined by taking the effective length and you divide it by the least radius of gyration. Right? So this is the general formula you use. Slenderness ratio is equal to effective length divided by the least radius of gyration. For rectangular or square section, the expression is modified to effective length again over the least lateral dimension. That is effective length divided by B. So if you've got a rectangle, you're going to have cross-sectional dimension B and D, so you use the B. For a square, there's no issue, you use B, but for a rectangle, you have to use B as the least lateral dimension. The maximum slenderness ratio for members carrying both dead and imposed loads is to be limited to 180 or 52. That is 180 if we're using the effective length divided by the least radius of gyration, and if we're using, if we're involved with rectangular or square section, then it should be limited to 52. Values greater than these limits indicate that a larger section is required. Right? So when you have values greater than that, it is indicating that you need to increase your section. Ratio of modulus of elasticity to compression stress. To obtain the modification factor K12 from table 22, the ratio of the modulus of elasticity to the compression stress should be calculated. Now, Young's modulus is taken as the minimum value for timber grade, and the stress parallel to grain is multiplied by the load duration factor K3. Right? So the ratio is equal to E minimum over K3 times the stress Now, eccentrically loaded post. Now, it may happen that a situation occurs when the direct load is applied eccentrically. So in those cases, when the applied load and the center of the post is not in line, an eccentricity is going to occur. Due to that, a bending moment will be induced, which is equal to the applied load multiplied by the eccentricity. right? So the moment as per the diagram is equal to capital F multiplied by eccentricity E. The eccentric moment induced should be checked by ensuring first that the applied bending stress is less than the permissible bending stress. And then the interaction quantity given by the formula is less than 1. That is, the formula provided in this sheet should always be less or equal to 1. All right. This will ensure that this eccentric moment is within sustainable limit.